In my previous video on the birth of electricity and magnetism, I mentioned at the end to stay tuned for Albert Einstein. I hope you enjoyed my previous video, and if you haven't, I will link it below. Albert Einstein is known today for his theory of relativity, but his discoveries and predictions across a range of fields helped lay foundations of physics in the 20th century and well beyond. Albert was born on the 14th of March in 1879, Württemberg, Germany, and died on 18th of April 1955 in Princeton, New Jersey, USA. He won the Nobel Prize for Physics in 1921 for his explanation of the photoelectric effect. Einstein is generally considered the most influential physicist of the 20th century. Early childhood. Einstein's parents were secular middle-class Jews. His father, Hermann Einstein, was originally a feather-bed salesman and later ran an electrochemical factory with moderate success. His mother, the former Pauline Koch, ran the family household. He had one sister, Maria, who went by the name Maha, born 2 years after Albert. Two wonders deeply affected Einstein's childhood. At the age of 5, Einstein was mystified by invisible force by encountering a compass. His fascination of invisible forces deflecting the needle. The next encounter happened at the age of 12, when he discovered a book of geometry, which he devoured, calling it his sacred little geometry book. Einstein was deeply religious at the age of 12. In fact, he has composed several songs praising God, plus chanting religious songs on the way to his school. However, this began to change when he started to read science books, where religious doctrines started to contradict it. This challenge, established authority, left a deep and lasting impression. Einstein often felt out of place and victimized by a Prussian-style of educational system that seemed to stifle originality and creativity. One teacher even told him that he would never amount to anything. Another important influence on Einstein was a young medical student, Max Talmud, later Max Talmy, who often had dinner at the Einstein home. Talmud became an informal tutor, introducing Einstein to higher mathematics and philosophy. A pivotal turning point occurred when Einstein was 16 years of age, where he had access to popular books on physical science, in which the author imagined riding alongside electricity that was traveling inside a telegraph wire. Einstein then asked himself the question that would dominate his thinking for the next 10 years. What would a light beam look like if you could run alongside it? Einstein's miracle year. Annus Mirabilis. In 1905, the unknown Einstein published 4 groundbreaking papers that addressed a series of major problems that lingered in the physics field of the late 19th century. Number 1. Direct evidence for atoms. Einstein showed how Brownian motion, the apparently random jiggling of small particles in fluids, could be explained as the effect of interaction with countless tiny, invisible atoms and molecules. Number 2. Particles of light. To explain why certain metals produce electric current when illuminated by short but not long wavelengths of light. Einstein argued that the light was delivered in tiny packets or quanta. The suggestion that light was both wave and particle aspects lay at the heart of later quantum physics. Number 3. Fixed speed of light. Since experiments had consistently failed to detect changes in the speed of light due to relative motions of source and observation, Einstein made an assumption that light speed was truly fixed. His theory of special relativity showed that, although Newtonian models remain correct in most situations, strange effects arise when two non-accelerating frames of reference move at very high relative speeds. Number 4. Mass-energy equivalence. Building on special relativity, Einstein now considered the energy of bodies at speeds approaching the speed of light. This led him to conclude that mass and energy are equivalent, summarized in his famous equation, E equals mc squared.
After the publication of Special Relativity, Einstein spent a decade developing general theory that could be applied to accelerating as well as non accelerating frames of reference. He published in 1915 the theory of general relativity and made a fundamental link between acceleration and gravitation. It showed that strong gravitational fields could produce similar effects to special relativity, and that all of these effects could be treated as distortions of space and time themselves. The key insights on the road to general relativity came in 1907. First, the stationary observer on the surface of the Earth is not in an inertial reference frame. They are being acted on by a steady downward accelerating force, which we call the pull of gravity. The second, therefore, in terms of the forces acting in a particular frame of reference, the presence of gravitational field is equivalent to constant uniform acceleration. Finally, the third one. So the effects of extreme gravitations are equivalent to those of relativistic motion. They create distortions of space and time, similar to those seen in special relativity. Now let's visualize general relativity by having a rubber sheet. Remember, the space is four-dimensional, but with time. But even ignoring that, let's take two-dimensional sheet. Large masses will warp the sheet downwards, corresponding to distortions experienced by objects within the warped region. The rubber sheet analogy should be used carefully though. It is not the representative of what's going on in the cosmos. Another way of thinking about distortions of free space dimension, at least, is to consider them as a pinching like the neck of an hourglass around massive objects. Einstein, in his later career, was developed to exploring the implication of special and general relativity and attempts to unify relativity with the very large different equations of quantum physics. I cannot do justice for Einstein's on a short video. I will dive more deeply into general relativity in going forward with space-time distortions. Let me conclude here why he immigrated to the US. He was a target of Nazi Party. In fact, his work was labeled as Jewish science, and teachers were banned from discussing it at school. He was forced to flee to America, where he contributed to the Manhattan Project, codenamed for atomic bomb, and helped the Allies win the World War II. However, after the war, he became a strong advocate for disarmament and is widely regarded as a pacifist. I hope you enjoyed this video. Please subscribe to my channel if you and also share this video among friends and family. And in my future videos, I'll be talking mostly on the cosmos and space time. So until then, cheers.